things I found at USC, we actually have other ways to store thermal energy. This is in the middle of the track field of USC, and then they dug a big hole and then buried underneath 3 million gallons of chilled water storage. So in addition to the thermal building, thermal storage of the building structure, here's another source of energy storage. Okay, you can pre-chill it, pre-cool it during the morning or midnight, and store it there. And during the afternoon, it'll get circulated. Okay, supplied to the buildings on campus. So now I'm proposing that we will use this as part of our optimization strategy. Okay, so it's there are things going on we can take advantage of. The other thing is that for this picture, now I'm going to use one of our own research lab buildings. This is the RTH building. My lab is on the 4th floor there. So we'll put wireless sensors to measure temperature, humidity, light, and hopefully also the number of people going in and out of the rooms and so on. So we're going to have several floors wireless with the wireless sensors trying to test this there. Okay. So this is also, you can see people who are interested in this project. Cisco and Johnson Control, of course. I don't know if you have Johnson Control here. It's one of the major air conditioning suppliers. Okay. So with that, I'll conclude my talk. I want to thank the sponsors and collaborators there. Thank you.
Any questions?
Yeah. I actually have 2 questions. I'm going to be a little greedy if you don't mind. My background is not in control theory, but I'm interested in energy policy.
Oh.
Now, it seems like your model is based on shifting the peak consumption of power, the time at which peak consumption occurs. And it's relying upon retrofitting buildings, improving thermal capacity, as you said. Now, the chart where you have, the slide where you have savings shown, do those savings take into account the costs that go into retrofitting some of these buildings? Because there's a company in California that I believe does work on solid oxide fuel cells, for example, for energy storage. And they have their systems installed in larger companies such as eBay, so on and so forth. Yeah. And they said one of the impeding problems is the initial costs that go into retrofitting these buildings, so that even though there is some savings, it's not tangible. It's not. And then that brings me to actually my second question, and that is, I actually forgot.
Yeah, let's do the first one first.
Yeah.
Maybe I'll recall later. Good question. There are many strategies to respond to new ways of managing energy. Our approach here, we do not involve retrofitting the hardware or the building or windows or whatever. We use whatever is existing there. Okay. We may add maybe some wireless sensors or something, but those are small instruments. So we're looking at more of a control strategy which deals with how you manage it with the existing hardware and software. Perhaps a little bit more software later, but that's our cost. So there will be a cost, but not as much as if you had to replace the windows of the entire building and so on. So to address your question, I think that's one. But for fuel cell or other alternative distribution, generation mechanism, you do have to consider a significant amount of capital investment. There are many ways people are considering to manage the load or shift the load. And that happens to be actually one of the most important factors. It's not like we don't have the capacity to generate electricity. It is we don't have the capacity at a particular time of the day.
Right. Yeah. And I actually did remember my second question. So you mentioned the second most amount of power consumption occurs due to commercial HVAC systems. Yes. The Department of Energy had a report saying one of the biggest contributors to that factor is data centers, where the cooling systems required to run these consume a lot of energy. Now, those cannot be shut down or cannot be operated in a cyclic period. They have to be operated at a consistent period of time or consistent amount of energy over a period of time. Yeah. So is Is that something that would inhibit the model that you have in place?
I think the data center is becoming a big consumption factor of the electricity. But I would say if you put that into the sort of the sea of buildings that are being occupied by everybody, I would say it's still a concentrated important factor that one needs to look into it alone. It's an interesting and important problem. In terms of percentage of total energy that you have to use to cool down that data center, I would say it would not be a big factor. But if you just look at the particular data center within that site, it would be a big factor. Right. Yeah.
Okay.
Yeah.
Thanks.
Do you know, are human factors that people looking at this? Because if the temperature in the room is getting hotter at the same point of the day when we're tired anyway, because we just ate lunch, then productivity would go down.
Oh yeah, of course, and they'll sleep.
So is that side?
Yeah, and that's another side of this energy issue, is that it has a lot to do with how people behave or change their behavior, or adapt their behavior. The different culture has different responses to it. I think in Europe people are more comfortable if they need to wear a sweater, they will do it. Okay, if they that's when you pre-cool it, they might feel a little chilly, so they will have a sweater in the office. But that is a factor. We worked with the Berkeley National Lab, and they actually studied how people felt about the strategy, the pre-cool strategies. And they get a survey at the end of the day or after a week. They say, we did something last week. Did you feel anything different? so some will say, oh, yeah, I did feel cold or something. But yeah, it has to meet the satisfactory factor of the occupants.
MPC, you saved 28% in cost by using the MPC control. Do you have an intuition if you use another type of control to do it? Right now, it's pretty much you can do it.
I think the savings is relative to another very sort of very bad baseline. If you compare it to the sort of pre-cooling strategy, open loop wise, you just step up its savings maybe 5 to 10%, not 20%, 28%. The intuition I would give that if you use another multivariable control strategy and you tune it well, in that you won't ask for something that's not physically implementable, then it would be fine. But
not physical
yeah, which is negative. Let's say you ask for something negative of what the equipment can deliver. Okay, but because we treat our comfortable zone as constraints. Okay, if you use LQR or LQG, then that does not have an explicit way to enforce the temperature to be within that zone. Then you might have to really tune it to be very carefully so that it doesn't go above the comfortable zone.
The actual application.
Yeah, I think MPC is chosen because it has a good way to deal with the hard constraints.
So if there are no more questions, let's thank again the speaker.